6.3, radicals as rational expressions. So these radicals, like a square root, we now need to show them as exponents. So you can have a base, and it's going to be the exponent right there, the square root, okay? Exponent rules that we saw in 6.1 there, and that was enjoyable. We did not see any division of the exponents, division inside the exponent. Okay, there was division in the bases, right, like this one or even like this, but we never saw any division, right? We see addition of the exponents, we see subtraction of the exponents, we see multiplication of the exponents, but not division. That's what the roots are, is division in the exponent. We've seen the slide already. You have the index and you have the radicand. The radical is part of the index, by the way. But if that radicand had an exponent of, let's say, b, then what this allows us to do is to write this with the base x, but then we have a fractional exponent, specifically b over n. Okay, so the index for the radical becomes the denominator. The exponent for the radicand becomes the numerator of that exponent. So this is the first time we're seeing this division of the exponents. If by chance this ended up being some kind of fractional value that could be simplified, then we would. If it can't, then we won't, and that's fine too. It goes both ways. So sometimes what they'll do is they'll start with the radical and say, change it, please, into an exponent. Sometimes they'll start with the exponent, and then they'll say, please change this to a radical. Usually it works out better to change the radical to an exponent because it's easier to simplify from here sometimes, I guess. And if you can simplify this, then you can rewrite it back as a radical, sometimes with a lower index, which then makes the simplification of the original problem a little bit easier sometimes. Some examples for us. The numerator, like we just saw, the numerator of the fraction is in the exponent. The numerator is the power that's already there, like right here, right? You got, that's j to the power of 3, so it's j to the power of 3 over, and some students say, well, why is that a 2? Like I've talked about before, the denominator is a 2 there because the index is a phantom 2. If you don't see the index, it's automatically a phantom 2, not a 1 for radicals. Or k to the power of 23, so 23 is the numerator of that exponent, and then the 3 index is the denominator of that exponent, okay? And yeah, even if it's negative, so be it. We'll talk more about that later, but you can have a -5 exponent there, which would then be your numerator, -5, and then your denominator there is 4. If, by chance, you just have a -15 like that one right there, it does have an exponent of 1, which is why you see a 1 there for your exponent, and then your denominator there is 5. Okay, and that's kind of what this is showing right here. This is, I guess it's kind of the rule, but usually what we would want to see there is some kind of letter there for an exponent of x. So it ends up being x to the power of a over n, I guess, which we saw in the last slide too. Again, this is just in an effort to show you that you can rewrite if you don't like to see these square roots, which most people don't, well, most people don't like to see these either, but sometimes they're easier. To get started, that's all it wants us to do. Please take this rational, make this radical expression into a rational exponent. Well, I do see that I have a base 10, so I'm going to keep that base there. That's good. Let me write it in there. And then the exponent of 10 is 7, right? So I'm going to make my exponent a fraction, but with a numerator of 7. And then the denominator is the index for the radical, which is 5/7. I don't see that 7/5 can be simplified, so that's just all we want on this. Write this one as rational with a rational exponent. So again, we see a base of 18, right? So I'm going to have 18 to the power of, it's a fractional exponent. How do I know it's fractional? Because I got some kind of root here, radical, right? Now that 18 does have an exponent, you just can't see it. It's an exponent of 1, so that's my numerator. And then the denominator is the index of the radical, which is 3. 18 to the power of 1/3. That is all. Oh, I guess this one wants us to evaluate. All right. The negative. Don't worry about the negative. It's part of the numerator, by the way. If you, for some reason, if you wanted to, you could rewrite this as a radical, which has an index of 2. That's a square root, right? That's from the denominator there. Then that would be 4 to the power of that -5 numerator, right? Now from this, you would usually just reciprocate that, right? So we would show this as over 1, and then you can reciprocate that negative exponent. Of course, it keeps the square root there. Yeah, the square root, yeah, you don't have to show that one. But now, after flipping this, I now have 1 over the square root of what would be 4 to the power of +5, right? Because the 5 becomes positive after flipping that fraction. I just flipped the whole fraction right here as over 1. If you made this a square root of 1 over 4 to the power of 5, the square root of 1 is 1, so you end up with the same value here. I guess inside I really wanted to skip some steps. In any case, right here, let's evaluate that 4 to the power of 5, by the way. Here's what I want to do. I want to do this. I just worry so much. So, yeah. I'm going to take a quick shortcut to that, though. So my power of 5, right? Geez. Let's do this. Okay, so I got 4 to the power of 5 square rooted, right? So that's going to be 4 to the power of 5 over 2 on this. Here's what I'd like to do is change my base so that it's something that works with the power of 2. Why am I doing that? Because it should simplify much easier that way. The 4 right there, I'm going to make it 2 to the power of 2. Now, why would I do that? It's because I got 5 halves as another power there, right? So then the 2's become a phantom 1, and then you just end up, let's give ourselves more space. But then you get 1 over 2 just to the power of 5, which I can solve that. That ends up being 1 over 2, 4, 8, 16, 32. And that's even more simplified, which as a math nerd makes me feel better. There we go. Okay, now that was great.
You wanted that answer? You addressed it?
Part of our problem here is that students don't see this 4 as 2 to the power of 2. Try to look for those. Try to look for those, especially since this was, see how the denominator was 2? Usually if that's the case, I shouldn't say usually, sometimes if that's the case, then this base is something that can be raised to the power of 2, and it gets rid of that fractional exponent. So if I saw that it was like a 3, I would look for something that's a perfect cube here, right? And you just put in the calculator cube root of that and see what you get. Or in this case, the square root of 4 to see that it's 2 to the power of 2. Now, the other way you could have done this, sarcasm, I'm purposely putting it in here, but you could have typed in 4 and then put in the exponent button. And then you could have typed in the n over d button, and then the calculator would let you put in a fractional exponent. And then you could have typed in 5 over, so you went down to 2 and then pushed enter. Let's see what this gives us. 4 exponent, n over d, -5 over 2, enter. You'll never believe this, but it gave me this. All right, what about this crap? So remember your exponent rules, right? Let's take the 2 and multiply it by the 1/4. So it's 16 to the power of 1/4 times 2, which really is 16 to the power of 1/2. We'll do it in red. 1/2. Yes. In fact, yeah, so I'm going to take the long route on this one. You could just type this in, by the way, 16 to the power of 1/2. and it would give you the answer. So I'm going to take the long route on this one. I'm going to write the square root on this one, because that's, and again, it does have a phantom index there too, which we don't really care about. That's really 16 to the power of 1, which also we don't care about. And the square root of 16 is 4. Boom. Now, if you had typed, if by chance you had typed this into the calculator, it would have given you 4. But again, you do need to show some work on an exam. So a problem like this one, just remember, I would look at this and just remember that the 2/4, it can be simplified. Now, if you don't see that, that's fine. But what you'd probably have to do then is change that into, it'd be 625. It'd be the 4th root of that. And that 625 would be to the power of -2. Is that easier? I don't know. I like this one better just because it simplifies that fraction. I would always look at that fraction and just see if it can be simplified. It isn't usually simplifiable on the assignment, but if it can, like this problem was, then do, because this is a lot easier to deal with than this, because now that I have that, I can now have 625 to the power of a -1, and then I would have the 4th root of that. So that -1, just like we've seen before. Oh, because because I made a mistake. Yeah, it was a 2 right there. Thank you. Whew. Glad we got that one. So, but now this one, it's a square root of, you really don't even need that 2 right there, right? The -1 is good though. But yeah, that would be 1 over 625 square rooted. And actually, 625 is a perfect square for 25. So let's see what happens. I'm going to go back to the beginning, right? I'm going to go to my calculator. I'm going to type in 625 exponent, n over d, -2 over 4, enter, boom, 125, 1 over 125. Sorry, 1 over 25. 1/25, boom. So all this work right here is good. Again, this negative exponent, flip it. If it was, if this was like a 2 right there, -2, I would have made this a +2 at this point. But again, the path that you take to get here shouldn't matter as long as you get the same answer. And yes, on an exam, you do have to show some work. Yeah, man. Now, this is the way you type that in the calculator. This one, you could have typed this one into the calculator as well, the 4th root, right? So you type in 4, second, and then it's the same button there, the exponent button, 625 to the power of -2, and you still would have gotten the same 1 over 25 right there. This one, simplify this, and this one we can't type into the calculator, but I'm still going to use it because I like it. Here's what I got on this one. So I really have the 8th root of x to the power of 1/8. Like this. Now, does that help us? A little bit. But what I want now is I don't want that power of 8. I'm sorry, the index of 8, right? So here's what I'm going to do. I'm going to take that x to the power of 1/8, and I'm going to rewrite it. This 8 right here. Remember that would be all over 8 again. Let's make this a little bit, well, that's good. So this is just fraction division right there, which the calculator will do. So in my calculator, I type the n over d button in twice. Okay, so n over d, then I push n over d again.
164.
This, by the way, is just in an effort to get the exponent. So now I see I'm in the numerator, right? And I need to type in the 1/8 into that numerator. So 1, you're going to type in the 1, then you go down to the 8. So that's going to show the 1/8. But then I go down again into the other denominator, which is where that purple 8 is. And then I push enter. And it tells me the new exponent, x to the power of, so 1 over 64. Now going back to division of fractions, you would have made that 8 over 1. 1 times 1 is 1. 8 times 8 is 64. I don't know if that matters to you, but if you need to make that x bigger, then do whatever. Now I'm going to go back on this one. Yeah. So I'm going to go back on this one, and what it really was from the beginning there was x to the power of what would have been 1/8 there in the red, and then this 8 right here would have been another 1/8 right there, which again, it was just kind of like you were multiplying those two, which would have given you again x to the power of 1/64. This one, there's many paths to the simplified form of this particular expression. I'm going to take a specific path myself. So I'm going to take my radicand, my 9x to the power of 5, y to the power of 2 right there. Now, I see I've got the fourth root of this, right? So I'm going to take that fourth root right here like this and just make it an exponent of 1/4. Okay, because really you could just say that all that's to the power of 1 if you want. There's other more complicated ways to do that, but I just want to make that 1/4. And the reason that is because I'm going to take these outside parentheses here, which is to the power of 8, and that allows me to apply the exponent rule with 1/4 times the 8 right there. Okay, so the reason why this is nice is because now I have 9x to the power of 5, y to the power of 2 in its own set of parentheses. But again, 1/4 times the 8 right there would have just been 2. Now, yeah, this fourth root to this power of 1/4 is just a change of format. It does not change overall value. All I did there was change the way it looks. I did not change the way or what its overall value, which again, I think I've said this before, but that is a key skill in math. So now I've got my exponent of 2 on the outside of this parentheses. Again, just applying the same rule there. Now I can take my 2 and distribute it into all of the exponents, right? So that'll keep the same base as 9x and y, but the 9 base has a power of 2 times 1, which is now 2, 9 to the power of 2. X base has a power of 5 times 2, which is 10. And then y base has a new exponent of 2 times 2, which is 4. Now that's pretty nice, and that was fun, but 9 to the power of 2 can still be evaluated. 9 to the power of 2, 9 times 9 is 81. And then everything else there, just, we didn't really do anything with that other stuff. So this right here ends up being our final answer. I can't emphasize this enough, but what I did there was just one way to do this. Some students may, they may work with the 1/4 there and this stuff on the inside. Like at this point, you could have distributed the 1/4 into the parentheses, and then you would add that to the power of 8 and then distribute the 8. I don't know. You should still get the same answer, but it's just a different path to take in this one. Is that really the order of operations? Not necessarily. So sometimes these problems, you'd have to sit and think and look, which of the exponent rules is going to help me the most? And like I said before, changing this format from a square root or a root, a fourth root in this case, into an exponent allows you to just focus on the exponent rules. But you do have to make that first change in the beginning. All right, simplify this expression so it only has one exponent. We do have one base, so that's nice. Let's look at this basis right here. So here's what I got then. I got the same base, x. Right here I've got 1/5, right? So I'm going to write it as a fraction. Then I got my other fractional exponent, 3/4, right there. Since I'm multiplying the bases, it's not shown, but I just showed it. I'm adding the exponents right there. Now, at this point, I don't really care about the base, which is x. So I'm going to keep it. I need it. I just don't really care about what's happening to the exponent for the x. Maybe I said that backwards. I don't care about the x for the exponent. So this is addition of fractions right there. So we need common denominators, right? So I'm going to multiply these by 4. I don't really care if it's a lowest common denominator, by the way. That'd give me 4/20. And then multiply the 3 and 4 by 5, which would be 5/20, which we then add a little bit more space. Then I get x to the power of in 20ths. 4 plus 5, boom, 9. And that's what we want. Now, this takes us back into fraction addition, and I hope that was fun. I hope you enjoyed it. But, thank you. 3 times, I apologize, I'm trying to hurry because I'm almost out of time, but 15, 4 plus 15 is 19, thank you. That is a better correction. Now, I made that mistake because I did it by hand. Theoretically, I would not actually do that by hand. I would use the calculator, where I would type in 1/5 plus 3/4. Enter, and it says 19/20. And to me, that's better. I like to use the calculator. Again, you may want to show this at least for your work. But if you use the calculator for this addition, then you don't really need to show this step. But yeah, this could have written, because you are right, you could have written it as the 20th root of x to the power of 19, which is good, but yeah, they did want this exponent stuff, so this one is the one we want. Simplify this expression. This one's crucial because the 1/3 is not applied to the 5, right? The 5 does have its own exponent of 1 right there, so you need to remember that. It's part of the deal. I feel like this one's simplified, but here's what I think they want on this. It's 5, and then you can have the cube root, right? Because the denominator there's 3 of x. Now, again, you could make that x to the power of 1, but I don't really want it there. I like that. If you want to put the multiplication between there, even better. If you don't, that's fine as well. Just as long as you understand it's not 5 to the power of 3. It's the cube root right there. But I'm gonna call that one good. Yeah, unfortunately, I got to speed through this one. But the rules all still apply. Please focus on one individual value at a time. And if that means that you got to get rid of this parentheses first, then do it, okay? In fact, I would kind of assume that most students would need to do that right here. So let's do that, okay? So I'm going to take this -2/5 and multiply it by the exponents there. Now, it's going to give me the same exact expression here. Okay, but now I've got a base x to the power of 1/3 times -2/5. Put that in the calculator, you'll get the new exponent of -2/15. And then you got the base y, that's -5/4 times -2/5, which should simplify into 1/2. So at this point, now I would just focus on each individual number, but I did need to get rid of that parentheses first. Most people need to get rid of the parentheses first. Not everyone does. But now I'm just going to focus. I'll start on the x's, okay? So I will have a fraction, but I've got x to the power of 4/5, and then I've got an x to the power of -2/15. And that's just the numerator part, but then I've got in the denominator x to the power of -1/3. Now, these are all base x's, right? So I can just work with my x's. In the numerator, I've got a 4/5 and also a -2/15.
I would never work with my.
So these ones, since those bases were being multiplied, we add those two exponents. But the other one, the -1/3 there in the denominator, that was being divided, so those have to be subtracted. Why am I doing that? It's because what I would really like to do, in any case, I now have my base x, which is what I want. But all of this stuff right here, I'm just going to type in the calculator, you guys. Yeah, you can find your own common denominators and work from there, but I like the calculator method. So 4/5 plus -2 over, now 15, of course, minus negative. Whoa, I got to get out of that fraction. Almost typed it in wrong. Minus negative fraction 1/3. Enter. Oh my gosh. It says it's 1. So all of that we just did gives me x to the power of 1.
What just happened here?
This is the way that I did it. Yeah, some students would be like this -1/3, I would move up to the top, or even the -2/5, I'd move that to the bottom. It's up to you, okay? Because moving this to the bottom would just be 4/5 minus the 2/15. And then moving this x to the -1/3 at the top would have been a plus, which minus the negative is. Of course, I typed it in the calculator exactly like this, and it just said, you got x to the power of 1. Boom, there's my base x. But then I will work with my y's, which I got some on the top and the bottom. So again, Let's work on this one. So in the top, I've got y to the power of negative 3/4, and also y to the power of 1/2. That wasn't green before. And then the denominator, we got y to the power of 8/5. So this, all base y's, but now we got the exponents of negative 3/4. We got 1/2. And we got 8/5. So again, what are we going to do with those? Well, the two y's in the numerators were being multiplied, so we're going to add the negative 3/4 and the 1/2. And then since it's dividing by the y to the power of 8/5, we're going to subtract the 8/5. So you're welcome to do this by hand if you'd like, because it is very fun. I'm not going to, so I like my calculator method. So in the calculator, negative 3/4 plus 1/2 minus 8/5, enter. Oh, this one's pretty ugly. I got negative 37/20. Yeesh. I don't want the negative. We don't want any negative exponents in the answer, so you'll probably benefit from making this a fraction. The reason that is because by flipping the fraction, the exponent becomes positive. So now it's a 1 over 37/20. So over here, I don't really need the 1 in the numerator, so I can just put in my y to the power of 37/20 in the denominator there. And that's it. I'm going to keep the x to the power of 1. I don't know why. I just am. Now, if you had written this as x to the power of 1 times y to the power of negative 37/20, it won't accept it on the assignment. It only wants positive exponents, and then you'd have to remember to flip that, put that, just the y base into the denominator. So a couple different ways to do this one. I like to work within the parentheses, but some students like to just distribute this negative 5/6 to all of them. But I know if I only got two bases, x's and y's. So again, I still recommend stopping, just looking at the problem, seeing which way would be easier to simplify. Because if you distribute a negative 5/6 into all the exponents, it's a lot of work. Whereas if I just work with the exponents of just two different bases, then I can have just two distributions there. So that's what I'm going to do. I am not going to distribute the negative 5/6. Okay, so I'm just working on the inside of the parentheses, okay? So now you could work with all the x's, but you see those x's on the bottom, right? So I know from the x's, I have the x to the power of negative 5/7 on the top, and that's good. But there's nothing I can do with that. But what I do have on the bottom is x to the power of 1/2 times x to the power of 4/7. Now I'm not gonna worry about putting that into or working with that by hand. Okay, so what I want then is x to the power of 1/2 plus the 4/7, and so I'm still ignoring the x to the power of negative 5/7 on the top. But what I have then is 1/2 plus 4/7.
15 over 14.
Yeah, that's what I got too. So my denominator exponent is x to the power of 15/14. Now we go back and we see we got x to the power of negative 5/7. And applying the quotient rule for my base x means that you take the numerator exponent of negative 5/7, and we're dividing the bases, so we subtract the denominator exponent of 15/14. So again, I'm just putting this into the calculator to give me my new exponent for x, negative 5/7 minus 15 over 14, and it gives me a negative 25 over 14. Now, I'm not worried about flipping that fraction yet because this is part of my new parentheses with the negative 5/6 exponent, right? I now have an x to the power of negative 25 over 14. Now, if you did choose to flip this into a denominator, that's fine. It's not going to make a difference in the end. It shouldn't. But now that I have that, let's go to the y's. Okay, so I've got y to the power of 1/2 in the numerator, all over y to the power of negative 1/2 in the denominator. And this then becomes base y of 1/2 minus, because they're dividing the bases, minus negative 1/2. So you can put that in the calculator, but I know minus negative 1/2 there is going to make this y to the power of 1. But again, that's something I put inside the parentheses now, okay? So, this is what I have.
Wait a second.
Next up is just a distribution of the 5, 6 right there, right? Now again, it's gonna keep the bases x and y. So that gives us this negative 25/14 times negative 5, 6. And that will produce a new base x for me. So base x, let's see what this is on the calculator. So I got x to the power of 125 over 84, but then I gotta distribute that negative 5, 6 to the y. So that's a 1 times that negative 5, 6, which of course is just negative 5, 6. So now I got my new y to the power of negative 5, 6. Now, I don't want a negative exponent on this, so what I'm going to do is I'm going to change this into a fraction, right? So I got my fraction, I got my x to the power of 125 over the 84. But this negative 5, 6, if I have a fraction like this, I can just move it to the denominator, and that will change the exponent from a negative 5, 6 to a positive 5, 6. And that's as far as I need to go on this one. That's good. Now just be aware, some students prefer to distribute the negative 5, 6 into all the terms first. If you do, that's fine. You need to get the same answer here. We don't need to change these into their radical forms because these started out as exponents. So we're just going to keep these exponents as fractions, and that's okay.